Welcome to Zero Knowledge. I'm your host, Anna Rose. In this podcast, we will be exploring the latest in zero-knowledge research and the decentralized web, as well as new paradigms that promise to change the way we interact and transact online. This week, Tarun and I catch up with our friend Georgios Konstantopoulos from Paradigm. We chat about his move to become CTO of the VC firm, the team he's built, and what they're working on. We then dive into Foundry, a fast, portable, modular testing toolkit for Ethereum app developers written in Rust. We look at the tooling landscape, why they're making a bet on solidity, the different types of testing that smart contract developers are doing, the open questions about tools like this, that is, what happens when you introduce bridges or multiple EVM chains linked together. Basically, Tarun and I just get to ask Georgios all the questions we have about the project and get his thoughts about the space. It was really fun to catch up. Hope you enjoy. Now, before we kick off, I want to highlight an upcoming event from the ZK Validator, another project that I work on. So on April 15th in Amsterdam, the ZK Validator is hosting an event called Privacy in Cosmos. This is our fourth edition in a series of events that has been funded by the Cosmos Hub. We have a great group of Cosmos projects and privacy projects coming together for a full day of talks, workshops, panels. So anyway, I hope to see you there. The event is free, but spots are limited, so be sure to get your spot right away. We've added the link in the show notes. The next week, there's also a ZK Summit, but I'm assuming that by the time this airs, the spots are probably sold out. To anyone who tried to apply and didn't get a spot this time around, I'm really sorry about that, but we will be doing more ZK Summits in the future. We're hoping to do a ZK Hackathon, so I hope to see you at one of our future events. So now I'm going to let Tanya, the podcast producer, share a little bit about this week's sponsor.
Today's episode is sponsored by Electric Coin Company, the inventors of Zcash, who are building the next generation of zero-knowledge tech. With its Network Upgrade 5, Zcash will move to the Halo zero-knowledge proving system, removing the trusted setup and becoming shielded by default. They believe privacy is essential to delivering on the promise of a thriving and equitable Web3. With Zcash and Halo cryptography, ECC aims to usher in an era of self-sovereignty and economic and creative freedom. Visit electriccoin.co to learn more and explore the relationship between privacy, self-sovereignty, and economic and creative freedom. That's electriccoin.co. So thank you again, Electric Coin Company. Now here is Anna and Tarun's interview with Georgios from Paradigm.
Today, Tarun and I are chatting with Georgios, the CTO and research partner at Paradigm. Welcome to the show, Georgios.
Hello, how's it going?
Georgios, you have been a guest co-host a couple times back in the day, and this is the first time I actually get to introduce you as the CTO of Paradigm. Tarun's also here with us today. We're going to be looking at the Foundry Project, but I think before we do that, it would be really great to hear what you've been up to. What's new in your world?
So what's new? It's been a while since we last talked. I think what's new is that recently I've been more involved in building our internal engineering efforts. 2022 sees Paradigm from being, let's say, a more research-heavy, like hands-on company. We're also extending that to becoming software-driven and data-driven for all our investment processes. So we've been hiring up on all sorts of engineering roles for our portfolio and for our internal projects. Without diving too much into that, I've recently been spending some more time on open source tooling, such as Foundry, which I think is today's topic.
Mm-hmm.
You know, now that you're kind of the grand poobah of the engineering team, you know, kind of what are kind of the high level goals? You know, you guys have hired a lot of famous anons on the internet.
Oh,
so,
yeah.
you know, what's kind of like the overall like theme that you think about when you're kind of building this team out too? Because like, you know, there are a couple other examples, but it's pretty rare when the venture fund builds an engineering team. So what are kind of the challenges and benefits of that?
I think there's two angles here. One is on the research and one is on the internal engineering front. On the research front, a lot of the work that we've been doing has been in the realm of supporting portfolio companies, designing new mechanisms. And in particular, for these skill sets, we've been on the lookout for very skilled solidity engineers. Recently, if you see, we hired T11S and Frankie is Lost on Twitter, who both of them basically were tweeting a lot about high quality solidity that they were building, and it seemed like a good fit for us. And to be clear, I don't think anon or not matters. Age, not a problem either. We're just interested in the best talent across the board. Now, on the internal engineering projects, I think there is a lot of data in the market that is not being used properly. I think that our needs are a bit more unique than what out-of-the-box tooling may provide, or out-of-the-box tooling may just not be fast enough or cost-effective or just simply not flexible. So we're gearing up to basically build that out for ourselves.
You've also been doing a lot of, at least a way that I have seen kind of the research and work you do come out is basically disclosing exploits to teams before the bug gets used for bad purposes. Like a lot of these, what do you even call these? Disclosures, like kind of posts where you reveal, oh, we found a bug and we want to let people know before something bad happens.
I think disclosure is the right term here. On our team, there is Sam Cizison, who I think is probably the best hacker on Ethereum and maybe other chains in the future. We'll see. Where basically Sam is always on the lookout for other projects, maybe has some automated detectors set up for identifying interesting hotspots or contracts which may get exploited. And basically, anytime there's some alert or anytime Sam is like, oh shit, there is something going on, he will contact the teams building the project, ask for contacts to the teams building the project, try to build a reproduction of the bug so that the teams can know what the issue is, and then responsibly disclose, patch if possible, and save the day. And this happened multiple times over the year.
Yeah.
Most notably, there was one hack where he saved about $350 million on a sushi swap related contract. And even more recently, he rose to the first rank on the Ethereum security leaderboard for finding critical vulnerabilities in Go Ethereum.
Wow. Some of the people you mentioned having hired kind of anon, are they truly anon to you? Like, as a company, do you have to kind of know who they are to be able to employ them? Like, you're not a DAO, you know?
Perhaps.
Okay.
We like to know who the people that we work with are, although we're very protective of their identities and we respect everybody's privacy to the utmost.
Got it. Today, what we really want to dive into is the Foundry Project. Before we do that, I wanted to sort of lay the scene of like where it lives and what is similar to it. Like kind of what came before, what tools would people be familiar with that it aims to kind of like replace or add to?
Yeah. Foundry is an Ethereum development tool, and more specifically an EVM development tool. So it's not tied specifically to Ethereum. It can be used for Polygon, Optimism, Arbitrum, whatever other EVM chain exists. It is a testing framework in the neighborhood of Truffle, Hardhat, DAppTools, Brownie, and all the other tools that have existed over time. And its core objective is to give you a good testing environment. And why is that important? It is because smart contracts need to be tested properly, because if they're not tested properly, edge cases exist, and these edge cases tend to cost people money. And whenever something bad happens, you see headlines with X million dollars got lost into this hack. And turns out there's some missing check.
Is it often the hacks we were just talking about that like Sam, actually, how do you say his name again? Sam's son?
Sam says his son, but there's also a very specific branding page on his website for people writing it.
Okay, Sam CZ's son. Was Sam's, those exploits that you just described, are those the kinds of things that these type of tools are meant to find, or are they bugs at kind of a different level?
These are not tools that automatically detect bugs in any way. These tools typically have a bit more limited scope into what they can find for you. Testing frameworks are there for you to get confidence that your code is supposed to do what you wrote it to do. Mm-hmm. So when you write some code, you write tests, and the tests say, okay, 2 + 2 is expected to equal 4. Whereas if 2 plus 2 in some of your functions ended up equaling 5, clearly there is a problem. So whenever a developer writes code, they have this very hot feedback loop in their system, which is write the code, build it, test it, debug it, right? And you keep doing that over time. And what's important is for the developer to have this feedback loop very optimized. So you want both the build process and the execution of the tests to be very fast. And this is where Foundry kind of comes in as a tool that covers the gap from previous tooling, which traditionally has been a few times slower. And we can dive into that in a bit.
Yeah. I mean, can you share with us a couple examples of the previous tooling? Because tooling has been around. There's things like Truffle, there's dApp tools, and I guess Hard Hat sort of goes in the same category?
For sure.
Okay.
So right now, according to the latest developer survey that was executed by the Solidity team, Hard Hat is the most popular developer tool, followed closely by Truffle, then it's Brownie, and then there's, the newer ones like Foundry and dApp tools. So there's a core difference between the two, that in Hard Hat, Brownie, and Truffle, you write your tests in a different language than what your actual code was. So your code language is typically Solidity or maybe Viper or any of the other newer languages, but typically Solidity or Viper. But it turns out that in Hard Hat and Truffle, you write your tests in JavaScript or TypeScript, and in Brownie, you write your tests in Python. And changing from one language to the other, as a developer, it has a lot of context switching, literally in your mind. Like when you're writing something, you're suddenly in one programming style, and then you change language and you're in a different programming style. And this has caused a lot of, let's say, productivity loss to people. And also, in the JavaScript libraries specifically, there has been a lot of incompatibilities with libraries. There's an infamous big number library, for example, for doing maths on very large numbers that people never are able to get it to work because they try to make JavaScript connect to Solidity. So dApp tools and Foundry, they take a different approach. They say, you know what? We want to write our tests like in every other language, and we're going to write them in the same language that we're developing our contracts on. If you look at any of the big programming languages, Go, C++, Rust, Python, whatever, they all have the tests in the same language. So here you also write tests in Solidity, code in Solidity.
What are you actually running? Is it like a library that's testing something? Is it a tool? Is it an application? Yeah, you sort of mentioned these two coding fronts. So what are you doing when you're doing a test?
Yeah. Originally, how this worked is that somebody had to deploy a testnet node. This was back in the day, it was called TestRPC. Then it was replaced by another thing called Ganache. And what these two do is that they give you a testnet node hosted locally without like any heavy database. And what you do is that you literally send network requests to it saying, deploy my contract, then call this function on my contract, then call this other function on my contract, then check that the value returned by this contract is this expected value. So a test literally is something that says deploy contract, call function, check some assertion. But in the different languages paradigm, what happens is that you deploy your contracts to a node and you send requests to that node. Whereas the difference here is that you're never deploying your contracts to a node in dApp tools and Foundry. You're instantiating a local Ethereum virtual machine and you're running calls against it in the same process. And this is the core ingredient that gives you a lot of speed boosts.
Cool. And when you talked about that node in the previous example, though, would that be like, that's a testnet node, I guess, right?
Yes, a local testnet.
Okay, it was also local, but in the Foundry example, it's an instantiation. Why is that different?
A node is composed of the EVM, some database, and a set of endpoints that the user calls to interact with it. Whereas here, we just never instantiate the whole RPC layer of talking to the node and just talk to the EVM directly. So it's you're closer to the metal in a way when you're operating in this way. And by being closer to the metal, you can be more effective and more fast.
It's faster, I guess. Yeah.
Yes. Less layers of abstraction.
How do you kind of view dealing with a cross-chain world in testing, right? Because, as people start building more and more complicated applications across chain, you'll basically need to have Foundry run, simulate sort of the multiple virtual machines, some notion of how the bridges work, and sort of like, what's kind of the way you're thinking about that? Are you thinking about like depth first search of like just add as many features to the existing thing until it's just like the perfect unicorn? Or are you thinking like breadth first search of like, how do we find the minimal set of features and then expand to as many new things as possible?
It's a good question. So basically, let's say I'm going to test a bridge that talks to Ethereum and Optimism. How do I test that? There's a couple of approaches here. One is that you think of the local chain as the place where you're testing. So let's say I'm on Ethereum. I will test just the Ethereum side of things, and I will mock the opposite side. I will say, instead of actually deploying the contracts on Optimism, I will say in my tests, when some call is made to this address, insert this response as if it was executed on Optimism, but not really. It's never executed on Optimism. You just say, act like it was an Optimism response. And this is a common pattern in testing. We call it mocking. It just means, don't run the actual computation. I'll tell you what to return if you receive some kind of inputs. So in this world, the multi-chain testing thing is not a problem because you just always say, give me the response that you expect. Now, if you want to properly integration test against both chains, it gets a bit more complex. And the reason why is because in the full node example that I said before, what you do is that you have one full node, another full node, and you get state from both of them and run your tests against them locally. However, here it is a bit more complex because you have instantiated an EVM with Ethereum mainnet state, and then you also need to somehow get Optimism state. So how are you going to interleave these two in a nice way? We have some ideas around how we can do this. We have not yet implemented any of this because it's a feature that nobody has asked for yet. So to answer the original question, I think we're going for basically get the best development experience on one chain, and then we'll see if we expand and how. Because right now there's a lot of gains to be made on just the single use case.
It clearly has caught on, people's, people have started switching to it because, or sort of maybe augmenting to some extent other tools because of its speed. So I guess that sort of was the natural question of like, do you just double down on that? It sounds like that's kind of your plan.
If you compare performance, one person recently in our support channels, they said that they had a Brownie repository where tests were running in something like 75 seconds without some form of advanced testing, which we'll touch on in a bit. And in Foundry, they were running in like 12 seconds or 13 seconds. So a 5x improvement is a lot. Now, MakerDAO's operations team, the ones that are deploying all the governance proposals, they had a test suite which when they were running it on CI, on GitHub Actions, it would take about 20 minutes to complete. And I think 1 or 2 months ago, when they were testing with Foundry, they ran it in 12 seconds. That's 100x faster. And if you're developing, this time difference, it literally is money for your business. Like you're paying your developers to write code. So how we see Foundry playing in, let's say, Paradigm strategic positioning is that this is one of the most scalable forms of value add that we can add to the portfolio, literally saving your developers time.
One interesting thing about this is if we look at the initial Foundry team, it's a very there are people working at multiple funds on it. If I think about the initial team as you, Brock, Transmissions, I guess to some extent. Actually, who would you call the Genesis team? And it's kind of interesting that you have multiple people, multiple funds working together on building this tooling that's pretty much pure public good.
Right. So how it started is that we had a library called Ethers RS, which is a toy project I had started 2 years ago for MEV traders to have better infrastructure, which is right now used by everyone basically that does MEV trading. And then one guy called Matt Sage had started to contribute to it. He's a Rust developer who was working with ChainSafe and is now working with us to improve Foundry. And then I had started working on Foundry, which at the time we were calling it DAppTools RS. He was one of the first people to contribute to it. So it started off very open source, toy project, let's see what we can do. Almost thinking alongside of the meme, let's rewrite things in Rust, like for fun. And then it turned out that it was quite good. So first it was Sage, then I think it was Brock Elmore from Nascent that started to contribute, who is also like one of the top contributors to the project. Brock is most known, I think, in the industry for yams, I believe, among other things. Yeah. There was a large incident back in DeFi summer for the people that were around.
When you think about it, that yam incident isn't even that big anymore. Like that would be like a blip.
Right, it is true. But it kind of underlines how much things changed the last almost 2 years. Like it's DeFi summer anniversary in 4 months.
Wow.
And the third, and I think the third person that has been like very, very valuable to the project has been Oliver Nordberg, who was one of the oldest. I think he was the first hired Aragon, who was sort of freelancing for a time, and then he started again also spending more time with us on Foundry. So basically the project sort of started very, very organic, very let's see what happens. Some open source contributors appeared, and the ones, let's say, that we felt their time spent on the project would be very valuable and would be a shame if they would be spending time on something else. Or I would feel very sad personally if I didn't have Matt, Oliver, or Brock like working on this. Basically, it was a nice way for us like to get them to contribute more. And Brock, I believe that basically all of their projects that they do at Nascent, they're using Foundry for development. So it kind of makes sense for them to also contribute to it, even though we're not involved in a more formal relationship. So I would say that is the core group. And then you will see a lot of people making periodic contributions, too many to count. I think there's about 75 or 80 people on the GitHub repo that are actively contributing, and there's about 500 like actual very technical people in the channels posting feedback, posting support questions, improving the project. So it's not like, it's a 500 or 1,000 people chat where people are asking when token.
This currently, it lives within the Paradigm repo though, I guess, right? It's still within your org's.
It is under my personal GitHub right now.
I'm kind of curious, like, does this live within the Paradigm like repository, or is it not? Is it open? Like, how do you actually keep a project like this? Where does it live? What are the licenses and stuff associated with it?
The GitHub project lives under my personal GitHub under Gacon/Foundry. And the license is a very permissive one. It's Apache, MIT. It's free for anyone to fork, contribute to it. Well, I don't think we really believe in the value of the project being in kind of putting a walled garden around it and trying to say, this is our property, don't touch it. The whole value of it comes from people coming in, contributing, talking about it, working with it. So, contributions and forking the project are actually a metric that I think makes it look successful rather than the opposite.
Cool. How do you see sort of maintenance for a project like this going forward? Do you see this being something that you're going to champion for a long time? Do you ever imagine this kind of being, taken on by another org?
Exit to the community?
I think the exit to the community part, the biggest problem with open source is always funding. So when you have an open source project, you need to figure out how to have a sustainable model for it. I think right now we are happy to provide and commit time and frankly, like some capital to it to keep it moving forward, as long as it is good for the industry, because we contribute back to the industry because we like the industry. So as long as we think that this is a project that is valuable for crypto, we will contribute to it in some capacity. Now, whether it is me spending all my time on it or somebody else, I do not know. But I think we really want this to succeed right now.
Who uses this product? It's for testing Solidity code. Cool. But like, do you actually, do you have it built? Like, are there projects that have it like kind of built into their pipeline? Like, what does it mean for this to be used, I guess is a question.
I think the biggest library contract that uses it right now is probably Soulmate. Soulmate is a project built by Transmissions 11, which is quote, modern, opinionated, and gas-optimized smart contracts for Ethereum. They're basically, it's a set of smart contracts that's a competitor to OpenZeppelin contracts, and it uses Foundry for testing. MakerDAO uses it for their operations. And then you will see a lot of like smaller bottom-up, let's say, efforts from individual developers or hobby projects. So basically, I think that right now Foundry has crossed the chasm for new developers or for people hacking. Basically, it seems like they are choosing Foundry. But the opposite, top-down big companies still adopting it is still ongoing because primarily people have all their testing infrastructure already written in a different setup. So it's harder to get them to migrate.
And testing is sticky. No one wants to replace it because it like you have the like who watches the Watchmen problem. When you change your tests, you have to make sure that your new tests don't break the old tests and they're backwards compatible. ... Right? And like that's a lot of work. That can be a lot of like huge amount of work.
I agree. So basically, there's a few things. We should think of tests as the glue that keeps our code from falling apart. So when you're changing your tests, you want your glue to be the same as it was before, because otherwise your code might fall apart, and you don't want that. So how we've built the project is that it's very easy to run it alongside whatever else you're already doing. So maybe if you have a bunch of hard hat tests and you don't want to remove them, but there's some areas of your code that you want to extend coverage for, or maybe some of your test is very slow and you want to make it faster, you can do some kind of incremental change where you run Foundry alongside Hardhat and you make incremental changes. And there are basically example repos for every framework now. There's like Truffle Foundry, there is Hardhat Foundry, there is Brownie Foundry. Yeah. So just to recap, bottom-up, smaller projects, I think we're in a good spot. Top-down, there is, let's say, some friction because of inertia, but I think that projects are very open-minded, and I think we'll see a few high-profile projects in the coming months release their new versions tested with Foundry. And we use it for all of our internal projects too.
And the history of like CI tools in like, normal sort of software stuff has always had this thing where like big companies will always have like a pilot project that's like a new project that's isolated from the rest of the code base. And then they'll try the new CI tool on that. And then if it goes well and it's faster, provides whatever benefits that it's supposed to, then they like slowly expand to like the rest of their projects. I don't expect this part of the development cycle to be different. There's like new projects within big orgs will probably start with that and then, osmosis after that.
Yeah, I think so.
You keep using the term tests, but there's also like the term fuzzing. Are they the same thing?
It's a good question. So think of it like that. A test says for inputs 2 and 2, the output is going to be 4. Whereas when you're fuzzing or testing for properties, to be more specific, you're saying that like calling the function add on A and B is always going to be equal to A plus B. So in a way, instead of testing for a specific test case, because testing just for that specific test case might not touch on all edge cases, instead you specify your test to be generic over your inputs and you run the same test for thousands of inputs. So instead of saying, 2 plus 2 equals 4, I will say 1 plus 1 equals 2. 1 plus 2 equals 3. And you keep doing it for many, 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 many inputs. Mm-hmm. And the idea is that when you're writing your tests and you test them over many, many, many inputs, you can get more, let's say, confidence that your code is safe. Because maybe, let's say, for an example, you have a division, so A over B, and it can be 5 over 2, or it can be 5 over 0. And 5 over 0 obviously does not work. So you want your code to be catching this edge case.
Okay.
But if you only wrote a test that tests 5 over 2, you wouldn't be able to catch it. So you need a way to be able to run your tests over as many inputs as possible to catch as many edge cases as possible. Does that make sense?
Yeah, I think so. But I mean, like Foundries, you could also use that for fuzzing, I assume.
Yes. So basically, this is property-based testing, which I admit we call it fuzzing, but it's not, for the formal verification people, this is not exactly the right term, but it's shorter to say fuzzing instead of property-based testing. So apologies there. So fuzzing in Foundry is supported very easily by just adding an extra parameter to your test. And instead of saying, x equals 2, you run your test over x. So instead of having no argument in your function, you say open parenthesis, x, close parenthesis, and your type. And anytime you just run your tests, your fuzz tests also run next to your unit tests. So tests without parameters are called unit tests. Tests with parameters, we call them fuzz tests. Now, the reason why this is very good is because you don't need to know anything about fuzzing. You just say, run my tests, you add a parameter, and conceptually for you as a developer, you just say, okay, my test is going to run over many inputs. Fantastic. But before that, and before how DAppTools also did that, which is a design that we took from there, people had to install extra software to run alongside it. And for developers, learning to use new software, installing it, maintaining it, putting it into their CI, it's a pain and nobody wants to do it. And so, for example, Trail of Bits' Echidna is a great, amazing tool that people should be using. But it turns out that people don't bother to download it and use it because the installation process has some steps, or because they need to run two software, like two different commands to get their tests running.
This is like dependencies, I guess, right? This is these build dependencies.
It is both requiring to have, you need to install another thing. So think of it like that. As a developer, you want to run one command, run build, run test, we're done. Install, build, test, that's it. Whereas here, you need to install, build, test for two things, and you have a different config file for the other thing. It ends up having a lot of fragmentation, and especially if you start to have many repositories, many projects, many developers that are not used to all of this separate tooling, it is a lot of overhead for you. So an explicit goal of Foundry is to reduce the mental overhead that the developer needs to have for doing their job at their peak performance. So what we say is that instead of requiring that you install a bunch of different stuff, we maybe re-implement some of the logic that other people have in different languages. In our favorite programming language, we bundle it all together and we give you a one-liner script to install it. So you install it, you build your code, and you run your tests, and these tests support fuzzing, and they support a lot of other good things. But basically, the goal is to reduce friction as much as possible. Like, for example, if you look up how many projects use Echidna right now, it's not at the point where everyone is open to using it as much. And I'd love to if it were the case, but it just isn't. It is still considered the power user tool.
Is it similar? I mean, I know you were, and I guess still are, a fan of Rust. And I remember you being kind of very, very, very involved in that community when I met you. Are you still?
Yes. So when we were meeting, it was when we were talking about, I think it was almost a couple of years ago when I was working with Cello and Alio on a bunch of the cryptography stack. So Foundry is also written in Rust.
Okay.
And in particular, it's written in Rust for two main reasons. One being performance, because Rust is just very, very, very fast, and that's our goal here. And two, Rust is very portable and produces very small binaries. Now, what this means is that I can have a process which produces a program that is a few megabytes big, like 5, 6, 7 megabytes, which has all the functionalities of Foundry for you. And this is very powerful because if you use Hardhat, for example, and you go to your node modules folder. So this is the standard folder that every developer has when they use Hardhat. And you go under the Hardhat directory, there's like tens of megabytes of data like that need to be stored. Or if you have an incompatible Node.js version, maybe you need to roll back to it. There's a lot of ecosystem related things that are just hidden complexity for the developer that you just don't have when you just have a tiny Rust binary program that you just download, you put it in your path and just run it. So the benefit here of Rust is cross-platform. It works on Windows, on Linux, on Mac, on M1 Mac, on ARM Linux, and it works and it's very easy to install. You can literally install it in 2 seconds.
Cool. Actually, one of the reasons I was asking the question about Rust, though, is also like in Rust, there's these automated tests that are always happening. And I'm just wondering if like fuzzing and these kinds of solidity tests, are they at all similar? Is it sort of like trying to recreate that? Or is it a completely different model and I'm a little off the mark? I don't know.
I think philosophically, we are designing the testing experience to look like Rust's in a way, like separating your contracts and your tests like in a certain way, following certain patterns and so on. And we indeed use a Rust library for fuzzing because, we support fuzzing in Solidity, but at the lower level, this ends up being some Ethereum bytecode that gets fed to a Rust fuzzer.
Okay.
So your fuzzing is only as good as your fuzzer. And we have identified certain points that we don't actually like in the fuzzer, and we're modifying it, and so on. So there are dependencies, to your point earlier, but we're trying to minimize them, and especially we want to have very minimum runtime dependencies, which means like you download it and you don't need to have OpenSSL installed, for example, which is a dependency that exists on many systems, for example.
I kind of want to go back to this idea that Tarun, you had brought up about the different EVMs and like sort of the like cross chain. But I actually wondered if, as I understand it, this is really built for, and by the way, I never know how to call this, like EVM for Ethereum, like the actual mainnet EVM, but I'm saying the Ethereum virtual machine. I realize when I say Ethereum EVM, I don't know how you call it, Georgios. What do you call the original?
They're all the same virtual machine. They're all the same virtual machine. Every EVM chain that exists uses the same underlying EVMs.
Are they not different though? Are they not altered in certain cases?
To be fair, don't forget this Gnosis chain exploit yesterday showed that they're not truly one-to-one, where like extra functions can suddenly get executed post. There is some difference for instance, for token standards, right? Like people have different ways of redeploying things automatically and stuff like that.
Oh, okay, sure. But so for people's context, yesterday, Tuesday 15, there was an exploit on the Gnosis on one of Gnosis chain's ERC20 tokens, because the default ERC20 factory from the token bridge is not an actual ERC20. It is ERC20 plus an unsafe extension. And this unsafe extension was abused and people lost money, and that was very bad. But it's not like the actual EVM running under the hood is different.
Okay.
Yeah. I just wanted to make that sort of one of the reasons I want to bring that up is that makes the design space for a tool like this, right? Like an IDE tool that's like almost can support all of these things. It has to be somewhat aware of that, at least those differences, right? And like keeping a list of those. Let alone if you go to some virtual machine with like a different ABI, but. The question is like when you're designing these things and you're thinking about bridges, how do you think about sort of these types of attack vectors and like making tests for them and making it easy for users to kind of find these types of things? Because in a cross-chain world, we can only expect these attacks from synthetic assets or like these like sort of implied wrapped assets to only grow, right? Like, and I feel like testing those is like going to be like tantamount in the future.
I think it's what we talked about in the beginning. In the cross-chain world, we would either need to... Chain A would need to know that the contracts on Chain B are deployed in a certain way. So it is up to the developer I think is the kind of cop-out answer, if you will. You just need to like give enough documentation to the developer, be careful, this might happen. I don't know that it's possible for us to warn against these kinds of things. Candidly, it almost feels a bit out of scope in a way, because I can deploy my bridge and I can add whatever code I want.
Do you think you'll have sort of like a module system? Because like one thing you could imagine is that, say, like each layer 2 or another EVM chain, they write their own sort of like modules that you can plug in that like automatically apply. You have the same piece of code for the ETH test and the Arbitrum test, but when you run the Arbitrum thing, you run the Arbitrum module, which also adds in like some built-in suite that does the mapping. Like, do you think that there'll be like an extension layer that people can write plugins like that? Because I actually think that might end up being a middle ground.
It's a great question. Plugins sound great until when you try to implement them, they introduce a lot of like smell, I feel, in your code. Like you need to allow for the plugin to hook into every piece of your execution. And this, in my experience, most developers don't know what the hell they're doing. So it's better that you just make a bunch of choices for them and say, this is the tool, it's opinionated, use it, that's it. And exposing a very, very, very flexible plugin system might not be the best way to do that. For this specific use case, I can see it working. But if that use case were popular enough, I think I would prefer integrating it natively. Because plugins, again, you need to fetch them, their runtime dependency, and so on.
Right, but in a world where there's like 5,000 EVM, I mean, there's probably not going to be 5,000, but in the world where there's like hundreds of EVM chains, let's say.
Right.
Possible.
I think we're open-minded to that being the case, and we reevaluate when that ends up being the case. In a way, it feels like the scarce unit here is time and people's kind of focus. And in order to ship something that does a 0 to 1 or a 1 to 100 improvement on the state of Ethereum tooling, we need to be very laser focused. So I think right now our core focus is we have a very fast test runner. We run it across all repositories that we see. We profile it. We see what is the slowest. And we try to reach something like the theoretical maximum of capacity that we can get. So we're going to keep improving the speed of the tests. We're going to keep adding more features for people to be able to explore more test cases. We're going to be adding coverage. We're going to be adding a formatter. We're going to be making compilation parallel. Basically, the idea is that we want you to run test, and in 2 seconds, everything is done, instead of it being 20 or 30 or 2 minutes or whatever. Whereas the multi-chain component, in a way, right now, at least to me, it feels like a distraction because it conceptually is in the realm of integration testing and not so much as unit testing. It's like testing a system, like a large system of 2 different smart contract suites. Whereas here, you're specifically testing one smart contract suite. And the whole crossing the boundary part feels a bit out of scope.
Right. I mean, I think, when I think about products like this, probably the most successful version of kind of a development testing environment like this, arguably, is JetBrains. And it took them a long time before they even added kind of this type of stuff, right? It took 10 years before they added this type of stuff. So I'm just more asking, kind of on a vision level, not just kind of a 2-year level. Come on. You ask other people their 'vision' as an investor, so I'm allowed to ask you your on a vision level, where do you see the 10-year dream?
Where's the hockey stick, Georgios?
I think the vision level is that basically a developer installs one tool and that tool covers all their needs. So if that need is indeed, I need to integration test across chains, we'll add it. Yeah, I think that is definitely the case. But basically, I'm thinking it is kind of shocking how we're 6 years into Ethereum development. There's a lot of experts that know how everything works and they have very hyper optimized workflows. But let's say for the rest of us, it is a bit hard for people to do very advanced workflows without being very multi-year experienced developers. And just to say the obvious, if the state of tooling in Ethereum or any kind of EVM chain is this way, imagine how it is in non-EVM environments. So a lot of the features that exist here, like testing against mainnet state or outputting call traces, which show how every subcall, the gas cost, the inputs, the outputs, everything, an interactive debugger, all of these things, you will not find them in other kind of programming environments. So it sort of paints a picture around how poorly developed tooling and how big of an opportunity there is to make things better in the tooling environment for any kind of blockchain.
Yeah, and I was going to actually get to that. Like, do you envision supporting non-Ethereum runtimes, let's say?
Again, good question. I think the thing that we are considering is Starknet. We don't have anything built right now, but the way the system works, it's very cleanly abstracted. It is compiler, EVM, test runner. So the test runner is abstract over the virtual machine or the runtime, and then you need a compiler and a VM. So I have identified a specific Rust repository for a Cairo VM, which Cairo is the runtime for Starknet, the ZK rollup network built by Starkware. So the idea would be we plug the Cairo Rust VM on Foundry, we plug the Cairo compiler on Foundry, and boom, Foundry supports a new system. Now, the reason why this is possible is because the semantics of Starknet are very similar to Ethereum. There are accounts, there are contracts. Contracts live at a certain address. You call the contracts by sending some hex data to some address, and the semantics are very similar. Whereas if you compare that to, let's say that if we want to support Solana, where the leading development framework is Anchor by great developer and friend Armani Ferrante, it is much harder. And so basically I can see us, I think we will support Starknet like later this year or whenever we have time. I can see us expanding to like other kind of languages that follow a similar account model as Ethereum or Starknet, but kind of expanding to the Solana style account model or the input accounts for each transaction model. It feels like it breaks the abstraction, so we cannot really touch it without building a new thing. And just to fill in on what I said before, Paradigm is an investor in Starkware, and we've been longtime supporters.
You just mentioned Starknet, and like I was going to ask you about stuff like ZK EVM, where they would do like Solidity compiles to something else. Does that actually change your test? Are there like significant changes that need to be made to that framework?
So there's multiple ways to do ZK EVM, and to be clear, I'm low conviction on how this will actually work, because there's a whole kind of works that you're opening now on how complexity of generating proofs for these goes. But basically the two ways to do it is either via transpilation, which is what Matter Labs is doing.
Mm-hmm. That's like Solidity that compiles down to something else, right? It's
yes,
not
yes,
the
yes.
EVM opcodes. Yeah, okay.
Right, so you have Solidity and compile to something that's not really VM, and it requires a custom compiler and so on. And there's the other approach, which I think is what Scroll Tech is doing.
And actually Jordy over at Hermes as well. They're also looking at this like, where it's like the opcodes are actually
right, exactly. So you run exactly the same computation on Ethereum on a Geth node, and then you take the execution trace from a transaction and you make a proof out of it. Mm-hmm. So basically in that way, the ZK part of the EVM almost runs as a sidecar process. It's nice because it's modular. In a way, you just have your Ethereum node that does things and you just generate proofs on the side, which means that this design is compatible with Foundry.
The second one, you mean? Like the
second design,
one?
yes.
Okay. Got it.
So the second design seems compatible because it just there's no modification. But I think the proving process for that is going to be very expensive.
Okay.
Now for the Matter Labs transpilation or different compiler approach, one could say that if the compilation process is sound or maps semantically one-to-one, like from Solk and ZK Solk, Solk being the Solidity compiler, you could say, run Foundry tests against your Solidity tests without compiling to the ZK bytecode. And if the transpilation, or if the different compiler maps one-to-one, and your tests pass in Solidity, then you would expect that your tests would also pass in the ZK context.
Got it.
And I believe that's how they're doing it. Like, basically, for doing it with Hardhat, I don't think that Hardhat can actually interpret the ZK bytecode.
I know this is probably outside of the scope of Foundry, but are there tests for the ZK part of ZK rollups? Is there any equivalent in the minute you get into that other level of cryptography?
So specifically for Cairo in StarkNet, for example, yes, there are testing frameworks where you write your tests either in Python or in JavaScript or in Cairo. So we can see how the ecosystem of Ethereum has kind of speedrunned itself into reappearing over there. And yeah, how it works is that they have a Cairo VM. Maybe it runs a node, maybe it runs in the same process, same things that we talked about in the start of the call. And you write your tests and they interact with the VM and they give you an output of how they worked. Again, this is because the semantics map one-to-one. It's very easy to build the new primitives based on how it was done elsewhere. On how tests work in other systems, I'm lower clarity of thought. So, what are the other approaches? Like the ZKVM, we talked about it. The Aleo approach, I'm not sure how Leo tests look like these days.
Yeah, I think one of the interesting thing is things that maybe might be a good future episode is to basically just get people from 3 different places. Maybe it's one Cosmos project, like Henry, one Aleo project, and Georgios, and we have what is this the framework? Because from whatever little I've dumpster diving in the code bases I've done, everyone seems to have very bespoke tests for the pure cryptography side of things, especially the ZK side. It seems it's very. It doesn't seem like there's some hey, here are here's the canned set of tests, because all the different snark mechanisms are just so different, and you have to test very different things, right? For instance, if you have a really big group, then you probably have to do fuzzing randomness testing, whereas if you have really small groups, you can actually just iterate through everything. There's stuff like that where there's a lot of weird nuance to each system that I just don't think there's some established battery. But what do you think there will be? Actually, that's maybe a better question. Is do you think say in 10 years there'll just be a set of default ZK tests, every proving system that's implemented in code has to pass this schema of tests. Of course, they'll get written and specialized to their particular implementation, but there's sort of in machine learning, there were always there's these they're kind of, I guess now kind of gauche, or people don't even care about them anymore because they're just so integrated into the testing framework. But ImageNet, CFAR, stuff like that, they're these canned data sets where everyone knows what the best possible output is. And every single new time there's a new framework, you basically have to prove that you can achieve state of the art and up to the same error and bitwise compatibility depending on the architecture you're running it on. As there's some set of tests that's true across all of sort of machine learning stuff, and so I'm curious if you think that'll happen here.
I haven't thought about this too deeply, so maybe the answer will be not satisfactory. I think a good way to get, let's say, compatibility across frameworks and whatnot is to define your tests as Json tests, or you say these inputs should give me these outputs. You put this in a file and you just say, this is the test suite. No matter what you do, this is what your test framework must run. So this is how, for example, you run Ethereum consensus tests. There's a big file containing a bunch of inputs and a bunch of outputs. And when people are testing out that their EVM implementation is correct, they literally run it across every single one of these inputs and they check, was the output the expected one? independently of the language. So this has been done in Python, in Go, in Rust, in like any language you can expect. Haskell, JavaScript, like every VM does that. Probably the most future-proof way.
Yeah. That makes a lot of sense. Actually, also, you said Haskell, and for some reason, I just realized that the Zero Knowledge podcast logo looks like the Haskell logo. It's like almost the same designer, like the Haskell Lambda. Yeah,
Really?
It's like actually kind of crazy.
What?
Yeah.
That's crazy. That was my idea. I'm pretty sure I never saw it, but it's funny because Frederick was really like the original podcast co-host was really big into Haskell. So I wonder if that had any, but like I came up with it. That's weird.
It kind of does. It kind of does.
Kind of.
You can cut this, Henrik, but I'm just going to send this. I'm sending a Telegram.
Oh, yeah. The colors look similar. You're right. Damn.
I didn't notice that until I just like somehow you said Haskell, and I was like looking at the ZK thing, and I was like, wait a minute, is this the Haskell logo?
That's so funny. No, I mean, yeah. I know where my influence, it was definitely not that, but that is very funny.
Yeah, but I do kind of think if you make like a vision board for the Zero Knowledge podcast, you should like have that. You should somehow
have that somewhere.
Like, merge the yeah.
Sure, I'd be down. We've definitely mentioned it on the show. Like all of these tests are all focused on Solidity code. I mean, obviously it's cool. Like the project is around Solidity, but like, do you think about a replacement to Solidity? Maybe when you wear a different hat, when you're not wearing the Foundry hat, are you also like, working on that, looking at new languages? Do you see anything ever coming in the pipeline that might replace it?
Contrary to popular opinion, I kind of like Solidity. I don't mind it. The semantics
How
are
contrarian.
simple. Solidity is fine, honestly. People like to complain about a lot of things. Like the language is not the problem when things go bad. People like to blame the language, but it's like people just don't know how to write secure code. And that happens in every language you will imagine. So first of all, we're working on making Foundry abstract over the language used. So right now it uses a package called Ether's Sulk. We're going to generalize that to be called Ether's Compile. So any language can be used for that. And the idea would be that, we can use it to compile Viper, we can use it to compile Fay, there's like a bunch of experimental programming languages. And to Tarun's point, this starts to look like a plugin system where you can plug whatever language you want in the code. And we can make it, if we wanted, we could make it look like a plugin, or we could just say, these are the languages. Now for more exotic languages, we have internally brainstormed something like a Solidity ++ type thing in the past, but it's unclear what that would do beyond opinionated changes in the syntax. I think with respect to targeting EVM, Solidity is quite good. So the question, I guess, would be, are you thinking about another virtual machine? I think the answer is no. Mm-hmm. And if you're thinking about other languages that target the EVM, I would say some syntactic sugar or some syntactical changes to Solidity maybe, but I don't know that we really need some kind of new language or whatever. It does seem like it hit escape velocity.
Yeah, I will say one thing we should take from the web development era in the 90s. Why do we still have JavaScript? Why did we instead build all these languages around JavaScript to compile to JavaScript?
Exactly.
Well, it's because whoever built the first dev tooling and got the highest distribution won. And for better or worse, none of the WASM stuff has totally found that fit. And it could maybe one day, but it sometimes it's a race to build the best dev tools. Whoever has the best dev tools first. I think that was true for JavaScript.
Agree. Fully agree. And, people saying WASM solves this haven't tried building something to WASM. So it's usually a hard thing to get something to work in WASM. And the most advanced thing that I know that works today is CosmWASM, which is the smart contracts runtime in Cosmos. And even them, they're trying to make a Solidity-like domain-specific language, which transpiles to CosmWasm, which ends up compiling to WASM. So yeah, I could see somebody building a small like transpiler that transpiles to Solidity, which has like nicer syntax that they prefer. But then, you need to audit the transpiler and like all that. So it's less than ideal.
Something we haven't yet talked about in the Foundry conversation are the two components that you've created. I feel like we probably should have done it earlier, but I want to make sure I get it in. So there's like Forge and Cast.
Yeah.
What are those two things? How do they map to what you've already discussed?
Yeah. So full disclaimer, this kind of separation of like calling the project Foundry and having multiple tools, it comes from DAppTools, where DAppTools basically had one tool called Dapp, which is the equivalent Forge, which is the testing framework.
Okay.
And they had another tool called Seth, which is the equivalent of Cast in Foundry, which is the Swiss Army knife. And now just to zoom in. So Foundry is a toolbox. We're not going to have just Forge and Cast. We're going to have more tools in the future. What these tools may be, we don't know. It might be formatters, linters, it might be static analyzers. It can be any kind of tool that makes the software testing process of a developer easier. Whether the tool gets integrated in one tool or as a new tool, it's TBD. So we just say Foundry is the umbrella project, and the two actual tools inside of it are Forge, which Forge is the tool that we use for testing, like Truffle, like Hardhat, like DAppTools. And Cast, you should think of it as a tool that you use when you're doing operations. Like you want to call an on-chain method and see, what was the value of this storage variable. Or you want to submit a transaction. So you can use it to like just do all your orchestration, to submit transactions, to query data from the chain. And it's basically what everyone that I know uses like for debugging things that go wrong. So, you want to check, do I own this token? And you can write cast die balance of gaconst.eth, and it will literally give you back things. So we're trying to make it like almost read like a natural language to some extent so that it's more user-friendly.
Slight step back, very high level, boring question. What's the etymology of all of these terms? Because like what's the, because like picking a name is quite important.
Yeah, so we brainstormed it a lot in the Foundry chat at the time. The idea that we had was it's Rust, so we want something that's a bit metallic. And because it's tools, we thought, okay, metal tools, okay, looks like a blacksmith style thing. So where does the blacksmith live? In the Foundry. So the Foundry is the place where all the tools are. And, the forge is the thing that the blacksmith uses to forge his tools. And the cast is like where all the hot liquid is in. Now, why one was called forge, the other was cast, it doesn't matter. It was like random choice.
Okay.
Yeah. We were considering doing a node. And, there's like the idea that we might call it, forge subcommand node. So forge node, or maybe we make it a standalone when we call it like blade or something like that. Like branding matters a lot. And I think like the whole, yeah, exactly.
Each new thing has to keep promulgating the message, the theme. So that's what.
Exactly. And if you go, for example, to the main documentation page, which is the Foundry book, you will see that we have like a little banner, which is like this guy inside his Foundry with like two metal things, like four casts with liquid metals falling down. Like it's quite nice. Like branding matters a lot.
It kind of echoes osmosis, actually, a little bit. I see.
Yeah, there's the meme of the dude that's doing things. Yeah.
Yeah. But this is true in a lot of open source. Like, Homebrew, like the Mac package manager, like everything is called like casks or like brew or like tapping a keg. And like the whole thing is built around like liquor references. And it might be one of the most used packages by developers in the world, right?
It helps.
Right.
And it's it sticks in your brain. You like very easily, you have these like mnemonics built in. And it's like very important actually to pick these things carefully.
Right. Agreed.
Georgios, I think the last time you were actually on the show, we talked about MEV. I think we were actually interviewing the Flash bots folks. So what does Foundry and MEV have any sort of overlap? Do you ever test for the impact of MEV in any of these things, or is it like a separate space?
So Forge has a subcommand called run, which you can run against mainnet state. So typically when we want to test when we want to make a proof of concept of something, such as Sam Citizen breaking a mainnet contract, he will write a contract and he will call Forge run, and you will see script passed, and he will be like, oh shit, we have to do something. So similarly, if you're building proof of concepts for arbitrage or for liquidations or whatnot, you can use it. Now, I have a template repository which is called Foundry Rust template. So the idea here being that all MEV traders, what they do is that they have some solidity that will talk to some Rust or some Python or whatever, and they need to deploy this solidity, they need to test the solidity, and then they need to have bindings to this solidity, like actual code that makes them talk to that solidity to use it in their bots. So the way that template is set up, it is set up in a way that you do one command, run your tests, or run your solidity tests, another command, run your MEVBot tests, and another command, run your actual bot with the bindings from Foundry. So in a way, I mean, this is a tool for testing, so it's not like it makes you money like for MEV trading, but it is built in a way that it can make your bot development experience easier.
Okay. So like I had Dean and Edgar on a few months or weeks ago, and they're building these bots so they could potentially use it. But it's not that it's designed for that. It's just their bots could be tested with it, kind of.
Exactly.
Okay.
Exactly. Although in their case specifically, I believe that they hook into Go Ethereum directly. They're customizing Go Ethereum, so this wouldn't work out there. But yeah, like there are many ways to do it. Like maybe they build a library that Go Ethereum calls to. Like there's a lot of ways to do this. So potentially.
Okay. So a topic we probably don't have time to dig into in this episode, but I did want to sort of mention quickly here is the idea of ZK hardware acceleration. Georgios, I know last time I saw you in Lisbon, you were talking about it. Is this something that you are working on? Is this something that you're looking at? I know there's new initiatives in the space around this as well with stuff like Z-Prize. So yeah, what are you doing on that?
I think we're very excited about the category. There's many approaches to doing it, and I think I'd be glad to bring on a guest in a future episode that can cover these topics.
Okay. You have an idea for a guest. I mean, I think it's worth an episode soon.
For sure.
Tarun, you and I last year, we talked with the Supernatural.
With Supernatural. Yeah. But they're doing all sorts of different stuff now.
Although they are running some prover stuff, right? Like I think they were working with Alio.
Yes, they're the ones who caused that like 10,000 block fork in Alio in the test net. As supposedly, that's what the Discord drama was about.
But you're saying that there's another group that we should potentially talk to. So cool. I guess we leave that open for a future episode.
For sure.
I think this has been a really cool kind of look into the project you were working on. You've been working on Georgios and Foundry. Where can people find out about it? We can add links in the show notes and stuff, but I don't know if you want to point people anywhere.
People can go to my GitHub and it's the first pinned message, or they can pin the first pinned repository, or they can find me on Twitter and it's going to be the first tweet that they see. So on twitter.com/GAConst.
All right. Sounds good. Thanks, Georgios, for coming back on the show once again and for sharing with us this project.
Thank you for having me.
It's always great to have one of the legendary Greeks of crypto back on the show.
Very nice. And I want to say thank you to the podcast producer, Tanya, the podcast editor, Henrik, and to our listeners. Thanks for listening.